Okay, so welcome back to the second half of the first part of conditional process modeling, moderation. If you remember last week or last month, we talked about just basic moderation design, how to do a continuous by categorical moderation. And the big thing I wanted to emphasize on that was how to just the steps to do it. Not so much this is how you do it on SPSS, although that's what I used. I really tried to emphasize the steps you can use, whether you're using R, whether you're using SAS, whether you're using Stata, whether you're using just Excel. You should be able to do this design or this analysis just following these steps that I'm giving you. And today is somewhat of an extension of that. We're going to be talking about how to do a continuous by continuous interaction. So we're getting rid of all of the categorical variables, all of the grouping variables, and instead we're only going to be focusing on continuous variables. When I say continuous variables, I mean like Likert scales. I mean, grades would be a continuous variable. Size of cut would be a continuous variable. Amount of fluid someone's on, amount of blood someone's given. In a hospital, the amount of continuous variables that are used are there's so many of them. So this design, I'm hoping, will be helpful to a lot of you. So just as a reminder for moderation, all this is a way to examine interactions with continuous variables. And like I said last month, whether it's a continuous by categorical or whether it's a continuous by continuous, we're going to be talking about today. So just as a reminder, a categorical by continuous moderation, you can have n number of moderators. You can have an infinite number of moderator variables if you want to. Now, that's going to be a ridiculous design. It's going to take you a very long time to run it and to unpack it. That is one of the issues with moderation, is it can be very time consuming just to run and to unpack, even for just one analysis. So if you have a lot of dependent variables, moderation design is going to take you a while. But with categorical by continuous, you can also have n number of categories. If you recall, I taught you all the basics for dummy coding, at least how to dummy code two groups last month. But you can have an infinite number of categories when it comes to dummy coding, so long as you dummy code them. If you wanted more detail on dummy coding, I'm happy to provide that. That's a little beyond what we're talking about here. But basically, it's just a way to code categorical data into zeros and ones. And then it also relies on recentering. If you recall, we had to take the mean from the continuous variable and then add and subtract a standard deviation to get above or below that mean. There's technically another type of moderation known as categorical by categorical. I can't stress this enough. This is just an ANOVA. Technically speaking, anytime you run an ANOVA, you're doing a categorical by categorical moderation design. Don't do it with regression to moderation. Seriously, just run the ANOVA. No reviewer is going to be impressed by your ability to run an ANOVA using a regression. Honestly, it's just going to confuse them, then they're going to get angry. And anytime you have an angry reviewer, it's never good. So if you have a categorical by categorical design, just run the ANOVA. Yes, you're technically doing categorical by categorical moderation, but do the ANOVA. And then lastly, what we're going to be talking about today is this continuous by continuous moderation design. So you can have n number of moderators. You can have an infinite number of continuous moderators. And so long as you follow these steps, you can run it. Again, though, the more moderators, the longer the analysis is going to be and the more difficult it's going to be. The other thing I'm going to also mention here is the more moderators and the more categories you have, the more participants that you also have to have. You need considerably more power with the more groups or the more categorical or continuous moderators that you're going to be looking at. So a little note on this, I actually still somewhat see this from time to time when I'm doing when I'm reading papers, and it somewhat makes me cringe a little bit every time. It was very standard practice, even 10 years ago, to perform a median split on continuous variables. So in other words, let's just cut it in the middle. Anything above this point gets a 1, anything below this point gets a 0, and take these continuous variables and categorize them into categories and then run the ANOVA. There's a lot of issues with that. Especially with something like something that's highly sample dependent, because the median values may not translate across the samples. Some of the other issues, then in my opinion, the biggest issues is that when you categorize a continuous variable, it leads to a loss of information and power. I've got an example down here. Cohen, again, one of the godfathers of statistics and power, I found that a median split can result in the loss of a third to two-thirds of the data because they don't fit into categories. And when he says don't fit into categories, you got to think about it this way. Let's say you have a 10-point Likert scale. Technically, it should be 11. You should always have odd number values, but we're just gonna use 10 points for right now. Let's say you do that median split right at 5. Everything above 5 goes into one group. Everything below 5 goes into another group. So the first issue is what happens to 5? It's right in the middle. Does it go in the top group? Does it go in the bottom group? So that's an issue. The next issue you're going to run into is you're technically saying that someone who is a 6, who scored a 6, is more similar to a 10 than they are to a 5. When in reality, they're only 1 point away from the 5 and they're 4 points away from the 10. But by median splitting them and by lumping them into groups, you're saying that those very different points are the exact same. Whereas you're saying these two slightly different points are completely different. Now, that may not seem like a lot when you're looking at full point scales. However, when you're doing this, you're not often working with clean data where everything's 1, 2, 3, and 4. A lot of times that median split may force you to separate a 4.99 and a 5.01. Those things are practically the same. But because of that split, you're now saying that they are completely different. And that 5.01 is more different from a 4.99 than it is from something that has a complete 10. So I encourage you, don't fall into that trap of median splits. I still see it from time to time. And I ask myself, how did this get past reviewers? But hopefully using moderation and continuous by categorical moderation, you won't need to do a median split because you'll know what you're looking for. So this is the example problem that I'm using. Again, I am horrible at faking moderation data. I've tried for years to create moderation data sets to use as teaching tools, and I just can't do it. It's very hard to fake, in my opinion. So this is, again, a real data set from a non-published paper, but a paper from years ago. So the question is, a professor is interested in factors that influence students' course grades. She looks at the number of books people read and course attendance as potential predictors. So in other words, to predict course grades, she wants to know if do people read more books, do they get better grades, and if they attend more, do they get better grades? And so the idea here is that there could easily be a crossover interaction between the number of books and course attendance to predict course grades, such that people who do a lot of both may have really high grades, people who do little of both, read little books and attend little, probably have lower grades, but they're probably somewhere in the middle for the other two. So we're going to look for that crossover interaction. Now on the bright side, these steps are almost identical to what they were for the continuous by categorical. So I'm going to exit out of this and I'm going to hide this panel. Maybe I'm going to hide this panel. Huh. Okay, let me slide this over then to where it can't really be seen or bother anyone. There we go. So I'm going to go to SPSS. Okay, so here's my data set. As you can see, I've got 40 participants in this. Number of books being read here with some people 0. I think the high is 4. There may be a 5 in there, but I'm pretty sure the high is 4. Attendance, how many classes did they attend? All the way down from, I think, 8's the minimum, up to 20 was the max. And then we have grades here. So going from a 41 all the way up to a 97 in this case. So we are going to follow these steps that we talked about last time and just follow them one by one. The first thing we're going to want to do is center our continuous predictors. In this case, we have 2 predictors, books and attendance. So I'm going to go to my descriptives and I'm just going to get the means and the standard deviations of both the books and the attendance. Again, use whatever stats package you want, use whatever method you need. You just need the mean and standard deviation of these two variables. And so what I have, I can see I've got the mean and standard deviation, and I'm going to subtract that mean from both of those variables. So for books, I'm going to call this send book for centered book. You can name it whatever you want. Number of books minus 2. Okay, I'm going to do the same thing for attendance. I'm going to do the attendance or send attendance. And I'm going to take attendance minus, what does that mean? 14.10. Okay. And so now I've created two brand new variables, some with negatives, some that are right on the mean, and then some that are going to be positive. That's what you're expecting when you center a variable. You're expecting some negative because you're putting that mean at exactly 0. So anything below the mean is going to be a negative. Anything above the mean is going to be a positive. And I think I mentioned last time that sort of the reason that we still do centering, although it does help with the recentering strategies and plus and minus standard deviation, as we'll see later, centering sort of started as convention because SPSS specifically back about 30 years ago couldn't handle large numbers. It handled things better when you got to 0. So people would center so that it would SPSS wouldn't literally take hours to run or days in some cases to run. So that's why recentering got started. But it's so much easier to interpret moderation now with recentering. So we've centered our variables. Step 2, we're now going to create interactions between the predictors. And if you recall, an interaction is all we have to do is multiply those together. So I'm going to take our new centered variables, so centered attendance times centered book. And I'm just going to call this variable interaction, or just int for short. Again, you can name things however you want, whatever is intuitive to you. And again, just multiply these together using whatever stats package you're using. Just multiply. That's all you're doing. Again, I really want you all to focus on a set of skills that you can translate to your own stats packages, because I know not everyone uses SPSS. So now I have my third variable here that's just my interaction between centered books and centered attendance. You'll notice in some cases there's 0. That's just because it was multiplied by the mean of book. That's nothing to be concerned about. This 0 is very different from the 0 that we had last month when we were doing a categorical and we had to flip our dummy codes. On the bright side, we don't have to flip any dummy codes for this. As you'll see in a little bit, we do have to do a lot of recentering. So let's just first see, before we make all these variables, I will always strongly recommend at this point, run your analysis. So see if you do in fact have moderation. I do know some people, and it's just personal preference, that will go ahead and create all of their cross products. They'll go ahead and flip their dummy codes. They'll go ahead and create all their recentering and then make all their interactions. And that's great. The issue is though, if your interaction doesn't come out as significant, that's just a lot of wasted time, because you shouldn't do anything else if your interaction is non-significant. So I always like to stop right here and run my analysis to see if I should move forward. The first thing I'm going to do is I'm going to put centered books and centered attendance as a step 1 for my regression. Grades is my dependent variable. And then in step 2, I'm going to put my interaction. So ultimately, I'm running a hierarchical regression here, where I'm running it in steps. Where step 1 just has my my individual centered variables, and then step 2 adds the interaction. Now, for those of you that aren't as familiar with regression, when I say a hierarchical regression, this does not mean that I'm running the interaction by itself. With a hierarchical regression, it means you're adding steps into it. Don't get it confused with stepwise regression. But a hierarchical regression means that you, as the researcher, have rationale for adding these predictors step by step. So you're adding this interaction into the second step of the regression, to where it's going to be running both of those by themselves. And then in the second step, it's going to be running both of those and this interaction at the same time. I'm going to request part and partial correlations, again, just so I can get that measure of effect size of my R-square. Confidence intervals are always nice to get, especially with more and more journals requesting them. The R-square change, I don't do a lot with it. I know some fields really like R-square change, so they can see exactly how much change is being, how much more variance is being predicted by the interaction. I'm not going to select it. No, I'll select it. I'll talk about what it means. Again, though, you probably won't find it as useful. The big thing that's important, though, is the part and partial correlations, just so you can get your R-square. And that's all we need to do. So we have our regression output. So this is what when I requested that R-square change, this is what it gave me. It gave me all this extra stuff to tell me, was there a significant difference in the model by adding that interaction? And here, sure enough, there was. My F changed significantly by adding that interaction variable. I don't know more what to do with that, other than just when I'm reporting, say, yeah, adding the interaction seemed to be important, but you can also get that information down here at the coefficients table. So I don't know why it's important to add there, but some people like it, and that's awesome. So with our coefficients table, again, it may not be labeled coefficients with what package you're looking at, but it's where you're going to get your B, your standard error, your beta, your T, your significance value, your confidence intervals, correlations. The first thing we're going to look at is I'm going to look at this model 1. This is just centered book and centered attendance by itself. And sure enough, what we can see is attendance predicts grades significantly, such that when you attend more classes, you have a higher grade. There's a marginal effect here, such that if you read more of your book or read more books, I'm assuming these books are associated with the class, but when you read more books, you also have a marginally higher likelihood of having a higher grade. So that's interesting in and of itself. However, here's where sort of the bread and butter of this interaction is. And you'll notice the p-values of our books and our attendance changed. That's always a good sign, especially with moderation, just because that's showing, yes, these things are depending on each other and they're depending on their interaction with each other. So you'll notice here that in our interaction, it is in fact significant. So when I see that, that's sort of my go ahead and make my recentering strategies, to flip my dummy code, to make my other interactions, because we've got sort of the main requirement for moderation, and that's we do have moderation whenever this is significant. So if you recall last time, we interpreted some of these values with the interaction. You can do that here, absolutely. And basically what this means is these values are, this is the regression or the slope, the regression value or the slope of the relationship between books and grades or attendance and grades at mean values of the other. So at mean values of attendance, we know that the slope for the relationship between books read and grades is 3.52. At mean values of books, we know that the slope for the relationship between attendance and grades is 1.32. So at mean value of books, so for someone who read an average number of books, which I think was 0, once we, it's all going to be 0 because we recentered it. So for someone who in the recentering strategy read 0 books, I think originally it would have been 2 books. But for those at 0 books, we know that there's a positive relationship, just that more attendance means higher grades. And for those at mean attendance, in this case 0, just because we recentered it, there's a positive relationship between books and grades, such that those who read more books had a higher grade. And again, those are in fact significant over here. So back to the PowerPoint. That's what we're looking at. The next thing we would definitely want to do is we would want to plot this. And if you recall, I recommended the Jeremy Dawson website because it's got some fantastic graphs that are pre-made that you can use to create your interactions. And I think they look really good as well. I've published with these graphs before. As a matter of fact, every paper I've ever written that's had a moderated regression has used Jeremy Dawson's graphs. They're really nice publication quality graphs that you can create really easily. So you'll notice here, this is exactly what the Excel file looks like. Whatever your independent variable is, you name it. So attendance, whatever your moderator is, you name it. It automatically puts it into the graph. All that these are these unstandardized regression coefficients. So for our independent variable, which we said was attendance, we look back here. Oh, I named those. I'm going to go actually back to here. So for attendance, our unstandardized regression coefficient, 1.32. All you have to do is put that 1.32 in here. For our moderator, which we said was books, 3.52. All we have to do is put that in there. For our interaction, 0.79. We just have to put that in there. Our intercept, which is our y-intercept. In SPSS, it's called your constant. Others, I think, call it a constant. I know a few just refer to it as y-intercept. 62.13. We would put that in there. On the bright side, our means are at 0, so that's easy. Those would always just be 0 as long as we've done this right. And then we would get our standard deviations, which which I recommended to request at the beginning when you were getting your means. So you can put that in, and that will give you this pretty graph here. It's, like I said, publication ready. They're good looking graphs. So I do recommend using this as an easy tool. It's a freely available tool to your disposal. So we've graphed it at this point. And we know, yes, this is the interaction that we're looking at. We can see there's this fanning behavior that's happening between low attendance and high attendance and low books and high books. So the question now becomes, what is significant here? Where are the significant differences happening? And you can do this a number of ways. You can, on the one hand, you can use the regression equation. And again, you get all of that in that previous step, y equals mx plus b. So y equals, so here's our b, which is our y-intercept, plus mx plus mx plus mx. And this mx is simply the slope and the value we're looking for of x, the slope and the value we're looking for of the moderator, and the slope and the value we're looking for of the interaction. In this case, it's going to be the same values as the slope, as the values we're looking for of x and m, and they're just going to be multiplied by each other. So that's one thing you can do, and I've actually computed it out here. So it shows us what these values actually are. And this gets us the grade. So for instance, of someone who read a low amount of books and also had a low attendance, their average grade is a 56.3. And all I had to do was put that into that equation. So our y-intercept times our slope, or a y-intercept plus our slope times times a negative standard deviation. So taking a standard deviation away of attendance, and mind you, this is the slope of attendance, plus our slope of books times our negative standard deviation of books, plus our slope of the interaction times our negative standard deviation of attendance times our negative standard deviation of books. And that gives us the score that someone would have if they read one standard deviation below the mean of books and attended one standard deviation below the mean of classes. We can do the same thing here for those who read a low amount of books but attended a lot of classes. So again, y-intercept plus our slope of attendance times plus a standard deviation, because again, we want to look at high attendance here. So plus one standard deviation, plus our slope of books times minus the standard deviation of books, because we're still looking at low books, plus our slope and all that information. That gets us our score of 57.88. That's what someone would make if they attended a lot of classes but didn't read a lot of books. And you can see down here, I've done the same thing for a plus standard deviation above books. You can see I've substituted a positive standard deviation in for all of those. And here it's just depending on whether we're looking at one standard deviation below in attendance and 1 standard deviation above in attendance, and that gives us our value. So we know that someone who read a lot of books but didn't attend a lot of classes, they would have scored on average a 56.7. But for those who attended a lot of classes and who read a lot of books, they actually scored a 77.63 on average. So again, all that I did was just take the slope equation, y equals mx plus b plus mx plus mx. I guess that should be y equals b plus mx plus mx plus mx. And just substituted our values in where necessary. We know our slopes, we know our y-intercept, and we know the values we're looking for because it's just a standard deviation above and below. And if you recall last month, I talked about why we use that 1 standard deviation value. First off, it's our recentering strategy, but second off, it's a solid distance away from the mean where we can detect effects, but it's not too far out there. Theoretically speaking, this line here, it only looks like a line segment because we're segmenting it. Stats packages don't care. A line is a line and it's never ending. This would technically keep going out all the way up this way. This would keep going out all the way out this way, and same thing on this end. No matter what, if you kept looking, let's say this was non-significant, but if you kept going out on this line, it would become significant eventually. Same with this way. This is non-significant, but if we kept going out on this line here and these two, this difference would eventually become significant, but it doesn't mean anything. This is why we use 1 standard deviation. It's just far enough away from the mean, but it's also not too far to where you're ultimately p-hacking at that point, or really more fishing. I think I mentioned last month that I do see some instances where people go 2 standard deviations. I've gone 2 standard deviations in a paper before. There's some good theoretical arguments for it. On the one hand, it does kind of mimic a 99% or a 95% confidence interval, but you have to have really good rationale for going more than 2 standard deviations away from the mean when doing a recentering strategy or when looking for these scores. So my recommendation is just leave it at 1 standard deviation. Okay, so we know our graphs, we know what our scores are here, and you can plot it that way using those scores if you don't want to use Jeremy Dawson's calculator. That's kind of your only other real alternative. If you don't use a kind of a pre-made graph generator, or you don't build it using the slopes, you have to compute these scores and create it that way. I don't like doing that personally, and I don't recommend you do it because it's frustrating and time consuming, especially when you have such an easy tool here. So as I mentioned, this is the y-intercept at mean books and mean attendance. So I've got it plotted right here. This is that y-intercept because again, it's the mean of both. This is again the simple slope of attendance at mean books. So I've also got that plotted here. So this is what the slope of attendance would look like for someone who read an average number of books. And this is the exact opposite. Someone who read or someone who attended an average number of class, this is the slope between books and grades. Again, really hard to plot on this graph just because of the orientation, so I didn't plot it. But if I had to flip that, if I had to put, say, books down here and let these lines be attendance, I could have plotted it then using this slope. And again, this is just our interaction down here, down at the bottom. This suggests, hey, go forward. You have something happening here. Let's unpack it. So the next question, we know the points, we know what it looks like, we know what the scores would look like for someone who read high and low amounts of each independent variable. So the next thing we have to do is unpack this interaction. Just like an analysis of variance where you run simple slopes or simple main effects or simple main effects for complex analyses, to unpack an analysis of variance, you have to run additional analyses, simple slopes, or flip dummy codes. In this case, we're just doing simple slopes to unpack these interactions to see, are these differences that we're looking at significantly different? So going back to this plot, is this difference significant? Is this line significant? Is this line significant? And is this difference significant? So that's what this simple slope analysis is going to do. So step 4, we're just going to create two new variables to look at the simple slopes with plus and minus standard deviations on books. And I'm also going to do it on attendance in just a minute, but we're just going to start with books. So let's first go back to SPSS, and we're going to create those variables. So I'm going to take my centered books, and I'm going to subtract the standard deviation, which was 1.432. So if you recall, recentering is flipped from what you would expect. To get above a standard deviation, you subtract. To get below a standard deviation, you add. So in this case, this is going to be someone who read above books because we subtracted the standard deviation. I had a graph or a kind of a visual representation of why you do that with the presentation last month. It's just because we're reshifting. If you want an interaction, and when you're running a regression, always looks at the mean. So if you want to get above it, you have to subtract the standard deviation from it to get that standard deviation shift, to get that above shifted to where the mean is. But again, just the big thing to remember is if you want above standard deviations, subtract. If you want below standard deviations, add. In this case, we want above, so I subtracted. And I'm going to do the same thing, but I'm going to add the standard deviation to get below. Now our next step is we're going to create our interaction with our new moderator in the IV. So we're going to use our centered attendance and the above books and the below books. So what do I want to call this? I'm going to call this bell book. No, I'm going to call this interaction first. So all I did was take the below books, multiply by the centered attendance, and just the interaction with below book. I'm going to do the same thing with above book. Okay, so now we have that. And now we're going to run new separate regression analyses to see how these interactions are working. So I'm going to analyze regression linear. Again, use whatever regression. This is just a regression. A regression is a regression, no matter what stats package you use. So I'm going to put, I don't know why that says block 2 of block 2. It shouldn't. Weird. I'm going to put my centered attendance in. This should be block 1. I think this is just a weird SPSS glitch. My centered attendance goes in here, and then I'm going to start with below book. And then in the next step, I'm going to put that interaction with below book. I'm going to put my grades in here. Well, they're going to request part and partial correlations here. So again, in step 1, centered attendance and below the standard deviation for books, and then the interactions between the centered attendance and below the standard deviation or below the mean of book. I'm going to run it. Again, I didn't request the model summary statistics. I don't find it that meaningful, and I showed you how to do it, so you should be able to replicate it. So if you recall, the first thing that we're going to want to look at that I recommended from last time was to see, does this interaction mimic what we saw in the last one? If you did it right, this should be exactly the same. So 0.79, 0.79, 0.027 for the p-value, 0.027 for the p-value. So that's good. That means that we've run this correctly. Your interaction's always going to be the same no matter what you do following these steps. So that's a good, easy way to tell if what you did was correct. Now, before we unpack this, I'm going to go ahead and run the other one. So I'm going to put my interaction with above book in here. And in the first step, I'm going to put the above book in as a step 1. So centered attendance and above book. and then my interaction between above book and centered attendance. I'm going to run it as well. So again, 0.027, 0.79, good. This was run correctly. So looking at this, you'll notice this looks drastically different from this. Well, this is the same, but our attendance is different. So ultimately, what this means is that for those who didn't read a lot of books, specifically if they read one standard deviation below the mean of books, there is no relationship between their attendance and their course grade. So you can see here this slope 0.184 is not significant. So again, at low levels of books, at one standard deviation below the mean of books, there is no relationship between attendance and course grades. Moving down to this next one. So at above the standard deviation of books, so at high level of books, however, there is a relationship between attendance and course grades. There's actually a pretty strong positive relationship between attendance and course grades. So we can, again, at one standard deviation above the mean of books, there is a relationship between attendance and course grades. And if we want to know how strong that is, this is why we request those partial correlations. All we have to do is square that 0.425, and that gets us our R squared, or technically our eta squared. R squared and eta squared are the exact same thing. So I'm just going to take out my calculator, 0.425 times 0.425, and that gives us 0.18. So that's actually a really strong relationship using the power primer suggestions, because anything above, I think it's 0.12 or 0.13 for eta square or R square is considered a strong relationship or a large effect. So for those who read a lot of books, as their attendance goes up, their grades also go up. And it's a pretty strong effect based on that effect size. So we can see here, I've got this pointed to these effects. So is the slope for attendance significant at high books? So high books being this line, this slope is significant. This is that relationship that we're looking at that I just unpacked for you, that 0.245, I think I'm reading that correctly. That is this slope right here. However, at low levels of books, so this line, as you can see, this is that slope. It's not significant. This slope is almost a flat line. Yeah, there's a little bit being captured here, but we can't know if that's a significant difference or if that's just up to random variance in chance. So the slope for attendance at low level of books is not significant. That's what this slope is representing. So if we wanted to interpret this, we could say at low levels of books, there's no relationship between attendance and course grades. Again, that's what we're seeing here. At the sample mean of books, if you recall, we plotted that, or we got that just from the main interaction analyses. The relationship between attendance and grades is positive and significant. However, at high level of books, the relationship between attendance and grades is even more positively and significantly related. So the more books you read, the stronger this relationship gets. So to get the highest grades in the course, you should read a lot of books and attend class regularly. So let's do it the other way now, because many of you may be thinking, okay, we've done high books and low books. What about high attendance? So we're going to go back and we're going to recreate all of these now at high levels of attendance, because we have to now recenter the other variables. So I'm going to go above attendance. I'm going to take my attendance here, and I'm going to subtract, I don't remember what the standard deviation was. The attendance, 4.278. So again, we want the above attendance, so we're subtracting the standard deviation. And I'm going to do the same for below. So I'm going to add the standard deviation here. Now I'm going to create my interactions between them. So I'm going to call these, and this is an interaction. I'm going to call this below attendance. So this is the interaction between centered books and below attendance. And now I'm going to do the same for the interaction for above attendance. Again, this is the same thing that we've already done. I'm just using the different variable. So center book by above attendance to create the interaction with above attendance. Okay, so we have our new variables here, our two new interactions and our two new recentering strategies. So let's run the regression. Reset all this. I'm going to go ahead and put my dependent variable up here. We're looking at the slope of books at different levels of attendance. So I'm going to put my above attendance here. So center books and above attendance. I'm going to put my interaction between center books and above attendance here. I'm going to request part and partial correlations. I'm going to go ahead and unpack this now. So again, what we'd expect down here from our slope, 0.027 and 0.79. Let me run the other one just so we can check it and we can unpack these together. Again, this is just a personal preference. I like unpacking my slopes together. For me, it's just easier. You can unpack them one at a time if you'd like, that's fine. Whatever's easiest for you. I just move my below attendance in and then my interaction with below attendance. Okay, so once again, we have what we would like down here, 0.027, 0.79. That's the same. So we've run this correctly because we're getting the same interaction. So what this means, yes, it was the same, it looked weird. For those who had a high attendance, for those who attended a lot, there's a very strong positive relationship between the number of books someone reads and their grades. So again, for someone who attends a lot, so at one standard deviation above the mean for attendance, the more books you read, the higher your grade. And so again, we can get that actual effect size by squaring our correlation here. So 0.403 times 0.403, and we get 0.16. So again, a very strong effect size here with at high attendance, more books you read, the higher your grade is. The other hand, down here, we can see that at low levels of attendance, for those who didn't attend a lot, there's no relationship between the books and the grades. It is, in fact, just coincidence that these slopes and p-values look very similar between a standard deviation above and below attendance and a standard deviation above and below books. They can be wildly different. So if those of you are thinking, did he just run the same analysis? No, I didn't. It just looks very similar. If you recall here, so at below attendance for centered books, it's 0.95. On the other hand, for below books at centered attendance, it's 0.8. So it looks similar, it's not. We can look at the same at above. So 0.003 for above books centered attendance. Above attendance centered books, 0.004. I actually had to do a double check myself just then because I think, did I just run the same analysis? Because it was looking very similar. But no, that's just a coincidence of this data. So that is how we unpack this. It's up to you to determine whether you unpack both sets of slopes. It also depends on your field. So for me as a social psychologist, they require pretty much to publish, you have to unpack everything. Other fields are a little more friendly. They only really make you unpack the specific question that you have. So if you were curious about how attendance or the relationship between books and grades at different levels of attendance, this would be all you'd have to unpack would be these two. On the other hand, if you're interested in the relationship between attendance and grades at different levels of books, you just have to unpack those first couple models that we had. Or you can just unpack both. Because again, it's so much information and it's pretty easy to run. Again, it can get very complex very quickly though, with the more models that you have. And so you have to ask yourself, there has to be an easier way to run this. And sure enough, there is. you don't have to do this the longhand way anymore, thanks to Process. Process is a free macro for SPSS, for R. I think they've just added it to SAS also. You can literally just Google Process. It's Andrew Hayes, who's, if you don't know who Andrew Hayes is, probably one of the premier statisticians of our time. Has written tons of books, wrote this program, or it's Preacher and Hayes. No, Hayes just does Process. I know Preacher helped on the book, but Preacher and Hayes, if you just if you just Google Process and Hayes, you'll find his website for the macro to download onto R, onto SAS, onto SPSS. This is what it looks like in SPSS. I think it looks pretty similar on the other two as well. So all you have to do is put your X variable, your moderator, it's a model number 1, and you'll get your grade, which is your dependent variable. You can request specific confidence intervals. If you're bootstrapping, you can request the number of bootstraps you need. It will center the variables for you. You don't have to center. I do, because Process can get a little bit wonky with their centering, in my opinion. You can also do centering not just a standard deviation, but you can do it at percentiles if you would like to. You can tell it when to probe interactions. You can make this more stringent if you would like. Again, I typically probe my interactions if they are less, if P is less than 0.10, because sometimes a really weak simple slope can mask a strong simple slope and make it look like it's non-significant. You can request a certain number of decimals. You can look for heteroscedasticity. You can get a lot of really nice things using Process. This is what the output looks like. It's a little less, in my opinion, a little less nice looking and easy to interpret than SPSS, but it's still the same thing. Our constant 62.13, attendance 1.31, 1.31, books 3.51, books 3.51, and then our interaction 0.79, 0.79. Same things. It gives us our V, our standard error, our T, our p-value, and our confidence intervals. It does not give you partial correlations, though. So you don't get a measure of effect size using this. That's one of the reasons I'm not a particularly. That's one of the reasons I run both, and that's one of the reasons I still run the old school method, is because I want my measure of effect size. The other nice thing that it will give you is these conditional effects. So it'll automatically recenter it for you. So at low levels of books, here's the effect. Here's the relationship between attendance and grades. At high levels of books, here's the relationship. Again, mimicking exactly 2.44, 2.44, 0.18, 0.18. You can also get a Johnson-Neiman method, which gives you change points. You can actually look at a very large number of differences. So here's ultimately at mean, and you can see where does the difference first start. So you can see at negative 0.4 standard deviations, that's where we get our first marginal difference. And when we get all the way up to 2 standard deviations, we get a pretty large difference. Again, that's what we would expect. And you can just see where those significance values start to cut off and where they start to change. So in other words, it starts to become significant when books is at negative 0.24. Any score below this is non-significant, so about 40% of the data, while any score above it is significant. And it'll also plot for you. It'll give you some syntax that you can just paste into a syntax code, and it'll plot it. Again, these are really ugly graphs in my opinion. You can kind of see what you're looking at. This is above a standard deviation, this is mean, and this is below. But it's an easy way to get that graph to look at. And all you have to do to get the other one is when you're putting it in to just flip what you have as your X value and what you have as your moderator. So in general, we've talked about centering variables and why we have to do it. We center to make it for ease of interpretation, as well as to get that recentering strategy. We create our interactions. We then test to see if the interaction is significant. Again, if you want to, go ahead and create your other values. I don't, because it's very frustrating to create all of your values and then run it just to find out your interaction was non-significant. So you've wasted 5 to 10 minutes of your life just creating interactions. Not a lot of time, but over time that'll add up. So I test my interaction then. Then I go through and create my simple slopes, recenter using plus and minus standard deviation, dummy code if I'm doing a categorical predictor. And so just a couple points to think about as we're finishing up. Keep in mind, be careful interpreting standardized betas. They're not entirely correct when it comes down to moderated regression. And the reason this is because of a cross product between the raw X and Z. I don't know if this is the case for other stats packages, but for SPSS it is. They've been standardized, which we already did by doing our recentering strategies. And ultimately, it's just much easier to interpret unstandardized scores. It's harder for us, and there's data to show it's harder for us to quite realize, okay, so this is a Z-score difference, and this predicts that versus this score predicts that. So I'm going to recommend just interpret your unstandardized scores. If you want to include your beta, include it, but make sure to include your actual beta value. I kind of showed you all how to write it up last month. When you're reporting stuff, you always have to have your B, you always have to have your standard error, your T, your p-value, and your measure of effect size or confidence interval as well. Your standardized beta can go with that. Some people like them. I don't like them personally. I don't see a need for them in moderated regression. But that's just up to you and what your field recommends. So I have a couple more examples here with data that I'm happy to share if anyone would like them. But that is it. Oh, it seems I've got some chat questions. Oh, how hard is this test? And I'm not really sure. It was not my test. So I don't really know what it's looking at. So any questions?
Can the videos be uploaded? I know, Laura, you're super busy, but can they be uploaded to the YouTube channel, or is it a different channel that I'm missing?
I'm having a really hard time hearing you.
I'm sorry, it's where my laptop is. The videos that for this one and the one before, can they be uploaded to the YouTube channel, Lori?
Yes, in fact, I've got thrice to do as well. I just kind of have a little backlog, but I will get them up as soon as I can.
Okay, no worries. Thank you.
Mm-hmm.
Any others? Okay, that's all that I've got. Again, if you want some of those other sample problems, feel free to reach out to me. I'm happy to share them. It's just publicly available data at this point because we share all of our stuff in Open Science Framework. So yeah, that's it. If there's no other questions. Thanks for coming, guys.
Thanks, Robert.